Hello everyone, welcome to my channel. This is the very first video that I'm putting on my channel explaining a very important problem which has been asked in many interviews and also in many online assessment exams. This is a very tricky problem, but also very interesting if you get the gist of it. So I am here to provide you a clean explanation so that this is with the cleanest part of code, so that this problem is something which you'll never forget and you can easily ace it in any interview which is being asked later on in any online assessment exam. So let's move into it. So I'll not bug you with explaining the entire theory which is written here. So I'll quickly explain you what the gist of the problem and what are the possible edge cases it's trying to explain. So what the problem is talking about majorly here is we are given an array called one. It can be any array of size maximum 100 and the particular index value can be of 100, right? So let's take an array 1, 2, 3. So this is a lexicographically arranged permutation. Lexicographically is basically the next like 1, 2, 3 to be in ascending order, right? 1, 2, 3, 1, 3, 2, 2, 1, 3. So you can see this is lexicographical order. So we can be given in any array, in any permutation of the array, let's say 1, 2, 3. So we have to provide the next lexicographically permutation of the particular array, which would be 1, 3, 2 for this, right? 1, 2, 3, next possible 1, 3, 2. Similarly, for 1, 1, 5, the next possible permutation would be lexicographically would be 1, 5, 1, right? There's also an edge case which the problem talks about is if what if we're given the the basically the highest lexicographical possible permutation, which is 3 to 1, right? So what we need to do in that case is we need to return the lowest possible lexicographical permutation, which is 1, 2, 3. So just remember these two cases which the problem wants us to handle, which is for any random given permutation, just provide the next permutation lexicographically, and for the highest possible permutation, just provide the lowest possible permutation lexicographically. So once you understand the problem, the thing you should look for next is what are the constraints, right? So here we can see the constraints for the length is 10 raised to power 2 maximum, and for a particular index also the constraint is similar 10 raised to power 2. So the problem can be solved in maximum of n raised to power O of n raised to power 4 also, but we don't want to talk about that because there can be many possibilities to write a brute force, and there's not a single one, so there's no point of me explaining the brute force. I'll quickly jump on to what interviewers are truly looking for in a possible solution, and if you provide one, there's no chance you can get rejected for that particular question, right? So I'm talking about straight to the brute force, which takes O of one space. Right. So here, let's say I've taken an array, here 1, 2, 6, 4, 5, 3. Here you can see this is not, this is a random given permutation, right? This is not the smallest or this is not the largest. We need to provide the next possible uh, permutation lexicographically, which should be for this, what it should be? It should be 1, 2, 6, uh, it should be 5, then it should be 3, and then it should be 4, right? So this is the next possible permutation for this number 1, 2, 6, 5, 3, 4. Now let's see how we'll reach at that. So what we want to do is we want to try start from the rightmost part of the array, because eventually we are providing the next possible permutation. So starting from the left won't make sense because it might give us the highest possible number, right? We want to take the next possible highest number. Sorry. So for this, we'll start from the right. And as I'm explaining you the logic, I also side by side will explain you the code so that you don't have to bug your mind to explain, oh, how do I relate the logic with the code, right? So I'll keep you in touch with code as well. So on the right, we can see I've started with K. I've taken n is my size of the array, and initially put k as n minus 2. K as n minus 2 means here 5. Sorry about that. So initially I've taken k at the fifth position. So what I'm checking is see whether k is greater than the zeroth index here, and check whether 5 here k minus 2 is greater than k minus 1, right? K is greater than k plus 1 is similar to saying k minus 2 is greater than k minus 1. Why we are doing that? because if our kth position is greater than k plus 1, let's say 5 is greater than 3, then there is no point in considering the right part or even the fifth index, because we cannot do anything with the right portion, which is 3. We can't swap it with 5 because it will lead to even smaller permutation. So we are looking for a number which is smaller than its rightmost index, right? So next right index, sorry. So here you can see 5 is greater than 3, so there's no point in looking into it. We'll do k minus minus. We move k from k minus 2 to k minus 3, right? So we reach at 4. We see 4 is greater than 4 is not greater than 5. 4 is less than 5. Okay. So that means there's a possibility to do something. We found a number which is larger than a number at a given index to the left. So we may arrange, right? What we saw here. We saw here 1, 2, 3, right? 1, 2, 3. Now there's a possibility which was third index, which was second index, the 3 value to be put instead at second place to make it next possible permutation number, right? So similarly we have hit a index here which can be swapped with the just to its right portion or to any of to any of its righter index to make the lexicographically next possible greater number. So we'll stick to this index. I've renamed the index from k minus 3 back to k, right? So once we reach this index, what we want to do, we don't want to swap it with any number or to its right? We want to find the smallest number which is just greater than 4, right? So in this way we'll provide a number in that index which is just greater than 4, which will provide the next lexicographical greater permutation for that index at least, right? And to its index previous to that. So for 4, what we'll do is we'll start a loop from 3. Here, as you can see, I've taken j as the last index and I'm moving j. This condition is not needed here, but just to be safe from the edge cases, I've written it. What we're checking here is the number j, till the number at index j is smaller or equal to k, right? As 3 is smaller than k, we keep on moving the jth index to the right till we are hitting a number which is just larger than k, right? So we saw 3 is not larger than k. Okay, we will move to j minus 1, right? This is j minus 1. So we reach at 5. We saw 5 is greater than k. Okay, we'll stop there. 5 is greater than 4. So what we'll do here is we'll swap them. Once we'll hit a number which is just larger than the number we have provided here is provided at k, we'll just swap it with the given number at this place. So what we'll do, we'll swap both those numbers. The permutation that we'll get here is 126543, right? So now we got this index. We got this permutation. As you've discussed above, 126534 is what we are looking for, but this is not the one. That's the next lexicographically greater permutation. So what we'll do here is we'll just, because we are coming while checking the number just larger than k and swapping it with the given number at this index, will have a permutation which will be something we want to reverse. Which will do something in descending order, right? As you saw, 4 is here and 3 is here. We don't want this. We want instead 3 to be here and 4 to be here. So what we'll do, we'll just reverse it. So that we'll have 3 here and 4 here. So this is the permutation which we are looking for initially, and this is what we have got here. You might be thinking, w- there might be possibility where we might not need reverse, right? Where we'll hit the number greater than the provided index at the very initial position, but that's not the case because we went because of their approach from the starting to look for the number which is just greater than the number at the given index where descending order is being broken, and to swap it with the number uh, just greater than the number at the index. So we'll reach a permutation at every single for every given array that we need to reverse. So for this question, you need to just remember the two things. One, to swap basically, I would say you need to remember three things. One, to find an index where the descending order is being broken, where the number is just smaller than the number to its right? So once you find that index, you need to find the number which is smallest but just largest than the number at the given index. So we started from right. At every single instance, you have to start from right. Started at right, we saw 3 is not larger than 4. We moved to 5. We saw 5 is larger than 4. We'll swap it. And after swapping, just reverse the array to the right of the swapped index. So 5 was swapped. So we'll just reverse the remaining right portion, which is 4 and 3 would be reversed to 3 and 4. So this is how we'll reach the solution we're looking for, and this is the approach which the interviewers are looking for when they're trying to say to you to write the most optimized version of the code. So I hope you get what I'm trying to explain. And if you're stuck at any part during my explanation, just rewatch the video and I hope you'll get it. So if you really like the video, do smash the like button and do subscribe the channel. I'll put more of these explanation videos for standard problems like this in the future also. So stay in touch. Thank you for watching.